This is part 2 of our lesson on section 6.5. Last time we looked at two theorems, the triangle proportionality theorem and its converse. These two examples go over those theorems. So we have a triangle inside of another triangle, and notice how this side of the small triangle is parallel to this side of the big triangle. What happens is that creates a proportion here. So this to this equals this to this. So remember how we called it A to B equals C to D last time. A to B equals C to D. So we'll call that lowercase d. 35 to 44 equals 36 to your unknown. If you know these three things, you can find this one. And you can do that just by cross multiplying. So we're going to take 35 times d. 44 times 36. We'll use a calculator for that. It gives you 1584. Obviously, this cross product, 1584 divided by 35, is going to give you your answer. So 1584 divided by 35 gives us an answer, and it's a decimal. .26, we'll call it when we round to the nearest hundredth. It doesn't always have to be a whole number. It would be nice if it was, but this fraction is going to reduce to this fraction. That's the idea. These parts are proportional. Now, the converse of that theorem would allow you to determine if this side is parallel to this side. So if this to this equals this to this, then the lines are parallel. So 50 to 90, that's the same thing as 5/9. Does that equal the same thing as 40 to 72? So we know that's 5/9. That's an awful looking 5. What does 40 over 72 reduce to? You can use your calculator or your phone if you have one. It's going to reduce to 5/9 as well. That's one way to do it. The other way is just to see if the cross products are the same. 90 times 40, that's going to give you 3,600. 50 times 72, that's also going to give you 3,600. So they are the same. So are they parallel? Yes. That's how you use those two theorems that we learned in this section. Now we're going to look at the other two from this section as well. This is theorem 3.6. It tells you if three parallel lines intersect at two transversals, then they divide the transversals proportionally. That might not make a lot of sense to you, but what's going to happen is we have parallel lines here. So instead of having two parallel lines, now we have three. Notice how there's no triangles here, but if this line would continue along with this line, it would make triangles. And what's going to happen is you can call this length A, you can call this length B, you can call this C, and you can call this D. And this behaves exactly like the triangle proportionality theorem. A to B equals C to D. Same thing with theorem 6.7. I'm going to put little lengths, little lowercase letters in for lengths instead of using the segment names with the capital letters. This same proportion is going to be true when you have a diagram that looks like this. A to B equals C to D. If a ray bisects an angle of a triangle, that's the ray. This is the angle that's getting bisected because these two angles are the same. What it's going to do, it's going to divide the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So this portion, we'll call it A, compared with this side, B, it's going to equal this portion C compared with this side D. So notice how we're using the same proportion in all of these. Here's an example. In this diagram, angle 1, angle 2, and angle 3 are all congruent. So what that does is that gives you corresponding angles that are congruent. That forces these lines to be parallel. When we have congruent corresponding angles, that makes parallel lines. So this diagram is exactly like this one. It's just turned. They're telling you from point G to point F is 120 yards. Point D to point E is 150 yards. Point C to point D is 300 yards. Find the distance H to F between Main Street and South Main Street. Okay, so here's how this is going to work. We're going to write our proportion. A to B equals C to D. We'll do the work over here. Now it's nice to write this out, but you probably didn't need to. Notice how 150 to 300 is 1/2. This needs to be 1/2 also. So we don't actually need to solve the proportion. We know that B is 240 yards. So that's what this is. Now, if you did this part, you still need to answer the question because they want you to find the distance from H to F. So H to F, it's a combination of 240 and 120.